Hi, everyone. Welcome to the AI and Data Speaker Series. So today we have a really exciting speaker, Dr. Vidya Setlur, who is head of research at Tableau, where she leads teams of scientists in research on everything from data visualization to multimodal interaction to AI and natural language. And over the last 12 years at Tableau, Vidya has led a variety of groundbreaking initiatives, such as developing and prototyping semantics and visual representations, and semantic icon encoding and semantically resonant color palettes, and also the Evisia system, which used natural language for analytical conversation. And also, Vidya led some of the productionizing of Tableau's Ask Data feature as a leader of both engineers and scientists on that product. And then prior to Tableau, Vidya was a principal scientist at Nokia Research for 7 years, and she earned her PhD in computer graphics at Northwestern in the early 2000s. So today, I believe Vidya is going to present some of her recent work on functional aesthetics and large language models for visual analysis. And as usual for the audience, we ask you to please hold questions until the Q&A session at the end of Vidya's talk, and we'll cue you when that time comes. And with that, Vidya, I'll just hand it right over to you.
Thank you so much, Evan. It's a pleasure to be here, and thank you so much for hosting me. Yeah, and Evan and I crossed paths way back in Nokia, so it's really nice to be here and kind of figure out, what you guys are doing and just share some of the stuff that I've been doing at Tableau. So let me just quickly try to, is it Shift Command F, full screen?
Vidya, I believe you need to go into a slideshow first.
Oh, okay, that's what it is. Okay. There it is. Okay, I am in full screen, so folks can see this.
Looks great.
Okay, thank you so much. Well, good afternoon, and thanks for the kind introduction and inviting me. And so in this talk, I hope to motivate the concept of what I mean by functional aesthetics and what role it plays in visual analysis. I'll walk through some different vignettes of how functional aesthetics can apply in various examples of my own research over the years. And since large language models are a topic of, a trending topic lately, I thought I'd speak about some of the stuff that we've been seeing in that space and where we're going in the future. So as mentioned, I am the Senior Director of Tableau Research. We are an industrial research team of computer scientists. We focus on innovation, bringing new ideas both to the company and to our customers. The work that is done on my team ranges from natural language interfaces, new user interactivity techniques, and most recently, various prototypes that explore large language models. And here are some examples of some work that we do, and we regularly show this to customers as well as publish a lot of our work at top-tier conferences. So let's start. I mean, this is lunchtime, so hopefully everyone has some lunch with them so that you don't feel too hungry. But imagine you're at a restaurant and you're served a meal in a beautifully arranged black lacquer bento box. One of the visceral pleasures of this lunchbox, I would argue, is its arrangement. There is an intentionality of food placement, which is juxtaposed with the sheer beauty of the delicacies. And so as you see here, the main dish occupies the largest portion of this container with the supporting dishes of cooked vegetables and pickled condiments supporting that. The black framing neatly highlights the shape of each part and provides an implicit guideline for order and hierarchy. So the meal is overall a visual delight, with each piece harmoniously playing an essential part that is functional, yet aesthetic. So we'll revisit this imagery towards the end of my talk so that hopefully by then you get a sense of how this plays a role in visual analytics and what we currently do at Tableau. So what do we mean by functional aesthetics? I would say it's a concept that combines the notion of perception, semantics, and intent that work together as a whole, creating beauty in meaningful design. And if there's one thing I'd like you to take away from this talk, it's that I argue that visualization is beyond just perception. I mean, we tend to think about just visual perception, but semantics and intent also play an integral role in helping people see and understand their data. So my talk is organized, at least the first part before the LLM piece is organized into three main themes. So I'll talk about some vignettes around perception, and then we'll get into semantics and then understanding intent. So the description of a single visual memory highlights the way our senses are so important in terms of how we experience the world. As Ansel Adams says, Yosemite Valley to me is always a sunrise, a glitter of green and golden wonder in a vast edifice of stone and space. And this really brings to light how strong our visual system is and how we use that as a sensory keyhole to make sense of the world. So let's start with a simple exercise to kind of understand or better appreciate the role of our visual system. So here is a table where if I ask you to compare two numbers, and particularly if I ask, which product subcategory is the most unprofitable? And if I give you a few seconds to look and scan at the table, you're probably, using your eyes to scan the table up and down, left to right, to figure out the right answer. But let's make it a little bit easier. By adding color, the unprofitable segments pop out. And this shows that our human visual system is indeed powerful. But I would argue that it's still hard to, look at these 4- and 5-digit numbers and do a mental comparison to figure out, where, and how close these numbers are and which one is actually the least profitable. But by converting those numbers into bars with color on profit, size on sales, it makes it faster for the eye to not only spot the reds, but look at the hue of the red and the length of the bars to find the right answer. So this is really one place where, the visualization community has really taken into account kind of our pre-attentive and attentive skills of our visual system to help people see and understand information around us. Okay, so here's another fun exercise. I mean, when I'm typically, giving a talk in person, I ask a brave soul to stand up and say the color, but not the word. So if I, give you a moment to parse through this, you probably are struggling and reverting to reading the word, but you're not alone, right? I mean, so this is what perception psychologists call the Stroop effect, and it happens when the semantics of the information doesn't necessarily align with our visual perception. And so we expect the colors and words to match, and they don't, and you have to exert far more concentration to overcome it. And guess what? This happens in visualizations all the time. So let's look at this example. The Stroop effect plays a role in how we encode data. Say I'm trying to visualize my produce cost, and Tableau's default color palette is assigned to these various items where, broccoli is assigned blue, for instance. And if you think back to the previous slide on the Stroop effect, because the colors are not semantically resonant to the meaning of these items, you're probably scanning back and forth to the chart and to the legend because that color mapping is not intuitive. And so one of the early pieces of research that I worked on with a collaborator, Maureen Stone, here at Tableau, was to better understand the semantics of data and how we can actually provide semantically resonant color palettes to a user. So this was some work that we published at Viz, and it's a little feature where as a user, I can load my data into Tableau, and it tries to compute the most canonical color for that object, if it is colorable, and assigns a particular color palette. So in this case, broccoli is green, carrots are orange. So, you're not dealing with some genetically modified vegetable, but the colors actually make sense. And we did some eye scan studies, and we found that people did not have to go back and forth scanning the legend and the chart when they were trying to make sense of the data. So continuing on the topic of perception and understanding the world around us, our visual environment generally contains more information than what can be processed within a glance. So we're constantly looking at signage around us to selectively focus on what matters to us. And, arrows are a very particular and specialized form of information that can encode interesting guidelines for depicting paths and directions and relation. And so back in the peak of the pandemic, we probably saw a lot of these signage around social distancing, or rather physical distancing, that became a new norm back in those days, where businesses placed these markers on the floor to guide customers where to stand in line, with additional creativity around branding and making that experience more personal, like this. The presence of arrows also affects how we interpret diagrams. Arrows provide visual perception of causality and direction. So in this case, it indicates that when force is applied on the lever, we can almost envision a rock being lifted up and the level of effort that it would take. So actions such as push, lift, move come to mind, adding movement to a static diagram. And so this physical phenomena that would normally take a paragraph of prose to explain is depicted in the diagram with the simple addition of an arrow. Maps have inspired a lot of the early roots of information visualization by depicting information as a communication process. And so cartographers have found ways to make maps more legible and useful, and they often simplify or eliminate less semantically important features, exaggerate more important ones, and resolve visual clutter to improve overall information quality. And this is a process called generalization. So I'm going to show you an example of how we were inspired by the cartographic community, where we applied these generalization operators to the context of resizing line charts automatically. So the case study here was, if we have a line chart with all its bells and whistles and all its detail that is typically meant to render on a large screen, if we were to render the same thing on a small mobile screen, or maybe a little spark line in a table, how do we intelligently cull information yet make the line chart at that particular scale useful and understandable? So this is just a video kind of showing how this prototype works, where I'm simulating the size modification using the slider. And as you notice, as the line chart is shrinking, a lot of the key elements disappear, and you get values for the peaks and local maxima. And as I bring the slider out again to the right, all these additional details are added incrementally, finally with all the grid lines and the axis labels as well. So this is one way in which we use perceptual operators to change the level of detail dynamically based on size. Let's see if I can, might have to move it to the next slide here. Okay, sorry. So as we wrap up this portion of the talk, the key takeaway regarding the usage of perception to understand data are, representation is context, task, and data specific, and it's really important to figure out what sort of information and elements ought to be emphasized, and making sure that that level of detail is useful when less information is de-emphasized. And so the second component that feeds into the notion of functional aesthetics is semantics. we as humans constantly seek meaning in our lives, and this is for things that make sense and things that we care about. This is one of my favorite pictures, where it depicts this conversation around a campfire, where, people are sitting around an artifact that helps ground folks together on a common theme. And, while there's no explicit, notion of semantics, this conversation among humans really centers around what that meaning is and what people are making sense of at that particular context. And so, whether it's having a fun dinner with your friends or a meeting at work or quietly observing nature, meaning is rather an abstract concept. And semantics, which has stemmed from, the linguistics and computational linguistics literature in particular, is a concrete way of expressing that meaning in data. And so with semantics, we can explore how words or signs combine to convey a concept. Icons are kind of my favorite type of symbols because they can often depict a lot of information in a really small real estate, and they are rather a ubiquitous form of what functional aesthetics provides, serving as this pictographic representation of intent or purpose. So many of these symbols might be familiar to you. Some of them might be very culturally appropriate to specific contexts, but symbols are a way in which we make sense of the environment, and they are present all around us. And so how does the notion of iconography and symbolism and semantics help us to create more functionally aesthetic charts? Intrinsically, charts can rather be abstract. So this is a scatter plot that was created by Carl Sagan, which is commonly called a Sagan plot, and it shows the relationship between brain and body mass of various animals. And in order to make sense of this visualization, your eyes are probably following these blue dots and labels to figure out a pattern. And it's a bit of a challenge, especially when the labels are not right next to those blue dots. So you kind of have to make sense of the pattern and then read the label and map the label to the appropriate dot. But by associating each animal here with a semantically meaningful icon, all of a sudden the chart becomes more useful to understand and follow. And so we implemented an algorithm that automatically assigns icons to charts based on underlying data. And kind of the motivation for this work came from observing customers who were publishing visualizations on Tableau Public. And many of them were taking a lot of time and trouble going out to the web, finding appropriate icons, especially for sports data, for instance, and mapping the appropriate logos to these labels by hand. And so we were looking at ways to sort of automate that process and reduce the friction in the flow of visual analysis by suggesting an icon library to users, especially if there are semantically resonant symbols available. But semantics is not just useful when creating charts. The process of mapping data to charts often involves a number of steps, including cleaning, shaping, transforming, and visualizing the data to create a story for analysis and communication. And we find that semantics can play a role in different parts of this visual analytics pipeline. For example, semantics can help with sensible data transformations. This was a problem kind of early in the day where we noticed that there were several ways in which our customers were expressing date formats. And many a times our tool was not adept at automatically converting strings to dates. And for those who do a lot of data transformation here in this audience will probably appreciate the challenges of something as simple as converting a string into a date format in order to create a trend line. And so what we ended up doing was we looked at the types of formats for which Tableau failed to automatically recognize a date. And it turned out that there were more than 10,000 ways in which customers were expressing date formats. I mean, all the way from a little endian to middle endian format, if you're in a UK influenced country versus in the United States, but also even fiscal years. I mean, every company has a different definition for fiscal years. So it can be pretty varied. And so we implemented a kind of a parser that actually looked at the context of the dates and tried to infer the right format. So if you look here, especially at the second row, 4/15/2008, because there are only 12 months in a year, the format here is probably month, date, year. So we came up with a parser that kind of looked at the context and figured out, okay, what are some possible ways in which the date can be inferred, and came up with some sensible options. And this thing was much more sophisticated, where we looked at the location from where the user was publishing the notebook or the data to come up with some plausible formats. And this parser would learn these formats over time as well. So one of the key takeaways, especially when we think about semantics, are, applying semantics data, adds meaning, and it can make that, data more understandable to the user. And a lot of NLP and AI techniques, particularly more recently, have explored how to bridge semantics and language with human understanding in the context of data analysis. And finally, perception and semantics can facilitate these richer analytical conversations with data, aspects that I'll cover in the next section of this talk. So the last piece of, the notion of functional aesthetics is intent. And this was a picture that I took back in Maui one day when we were doing a road trip. And this was as I was writing my book. And it really resonated with me because Max Weiss, an American scholar and translator, best summed up sort of the inherent sentiment of this picture that I took, where he said, let the conversation flow at its own pace. Don't try to rush it or control it. And you need to let go and be part of that conversation. So when we think about intent and visual analytics, really thinking about how we support a fluid, frictionless conversation between a human and a computer through data can actually lend to some interesting paradigms in terms of how we create interfaces and tools. And so analytical intent in particular is an analytical goal that a user focuses on when exploring data. And intent can be expressed quite literally when a user explicitly chooses the attributes of interest, say in a tool like Tableau, or expresses their intent through natural language. And so for the rest of this talk, I will primarily focus on the natural language component of this portion. So when we think about language for expressing intent, it can be rather vague, as its interpretation depends on the context and our inability to precisely determine the boundaries of such concepts. So one of the most prevalent kinds of vague language that we find users using when they're expressing their intent are adjectives. And these concepts appear through language and are expressed along the spectrum of concreteness, from, superlatives like tallest and cheapest, to these graded adjectives like cheap and low, which is kind of a subset of the data, all the way to something that is very fuzzy and rather subjective, like safe and healthy, because that can mean different things for different people. And so a good portion of my research here at Tableau has focused on exploring natural language to understand user intent and ask questions as seen in this example. So as a little personal, story here, I actually live in a town called Portola Valley here in the Bay Area. And, right by the San Andreas fault line. So, our town is extremely data savvy in terms of earthquake data. You know, we constantly look at it and, visualize it. There's a bunch of geeks in our town that, look at it. So as part of, developing a natural language interface, I thought, I'd kind of take that earthquake data and try to explore how we can actually support a conversation. So, I can begin by asking, find large earthquakes near California. And here I've bolded the words large and near because they are fuzzy. I mean, what does large mean? Does it mean a Richter, magnitude of 5 and greater, or, more than that? And what does near mean, right? Because near in California might be very different from, say, in the middle of Montana or a very busy metropolitan city in India, for example. And so the system that I helped implement, Evisa, basically looks at this input natural language utterance, find large earthquakes near California, identifies which of these are fuzzy concepts and makes kind of a reasonable guesstimate of what that might be and displays these sliders or widgets to the user if they want to repair and refine if needed. And this was kind of, it feels obvious, but this was, I think, one of the early notions of really understanding how do we kind of get around the impreciseness and the subjectivity around conversation, because when we're interacting with humans, we are naturally adept at doing that. But the moment that we're interacting with a computer, with data that often has kind of a misaligned mental model from a user asking a question to what the data represents, that makes it more challenging. So just kind of continuing on this example, if I were to ask a follow-up question, how about near Texas? Notice that I didn't explicitly ask for large earthquakes. I just said, how about near Texas? And so the system has to infer that intent from the previous context. And so this is an example of language pragmatics. And we do this all the time when we're talking to people, right? I mean, I might ask a friend, what do you want to do for dinner? And he might say, oh, let's go and have some Mexican food nearby. It's going to be really awkward if I say, okay, let's do the Mexican place for dinner then. I mean, it sounds repetitive or redundant, and we tend to build off of the previous context without really thinking about it. But what we find is users tend to apply that same pragmatic notion when they're interacting with a computer. So we need to think about how we want to design these systems to support these vagueness and ambiguity when people are expressing their intent. And so for these tools to understand the semantics of data, we found that using and leveraging external information that goes beyond the domain of the data helps for better sense making. And here are some examples of common data sets that websites and external information that we've used, like Wikipedia. It tends to have a pretty comprehensive knowledge about external events, for instance, if we want to explain trends, or Wolfram Alpha, which has a pretty comprehensive taxonomy around units. So in the Evisa prototype, especially for interpreting large, we relied on Wolfram Alpha in particular for mapping large to the Richter scale in earthquakes to come up with a reasonable guesstimate. Other semantic enrichment processes include, understanding basic unit types such as temperature. For example, I might ask highest and lowest temperatures in Fahrenheit over fall, and if the data is in centigrade, that the system will have to convert that implicitly. And if there are no seasonal ranges specified in the data set, it will have to come up with an appropriate temporal range to map to the season and to the hemisphere. So if I'm looking at the southern hemisphere as my data, coming up with that information, and just like in Evisa, providing these widgets for a user to not only understand the provenance of what the system is doing under the hood, but also having an opportunity to repair and refine those assumptions so that the system can learn that over time. So as users express intent through natural language, it is also important to provide scaffolds or guardrails for users to have a conversation with their data. So this is a system that we built called Sneak Peek that provides these visual auto-completion widgets to kind of scaffold the user in terms of what might be interesting in the data for them to probe about. So looking at this example about COVID data, and let me play the video. So I type in a question, show me cases in, and notice the widget appears for a map as well as the calendar. And I can pick on a particular entity, which is US because it was darkly colored, and the dashboard updates. And I can further continue my question and say on, and the system pops up this calendar widget, and notice that March is bright red because back in the day, there were huge spikes of COVID. And as a user, I have a more informed way of asking questions. And kind of the motivation for putting in these scaffolds were people told us, after interacting with these interfaces, they said, okay, we can frame a language, we get it, we can frame our questions, but we don't really know what to probe. What are some patterns that are interesting? So having a way to guide a user so they're not just shooting darts in the dark, I think is a good strategy. Let me just jump to the next slide. Okay, so as we think about ways to create tools and interfaces for understanding user intent, providing affordances, as you saw in tools like Evisa, for users to repair and refine these system defaults is important. And scaffolding does support intent, and how they're realized can often depend on the medium. And finally, language pragmatics data and the medium for where this data is consumed all need to work together as a whole to support this cooperative analytical conversation. Okay, so let's revisit this bento box metaphor again. And how does that play a role when we're thinking about creating functionally aesthetic dashboards? So hopefully by now you have this appreciation for how perception, semantics, and intent need to work together as a whole to create something useful for your target audience in terms of reasoning and understanding what are the key takeaways from the data. And I've personally always been, highly inspired by practitioners in the community who apply these concepts almost intuitively in their work. So this is actually a dashboard example from the Tableau Hall of Fame visionary, Kelly Martin, who sadly passed away several years ago, where she was looking at ways to analyze animal strikes on planes. And within this visualization, she embeds aspects of functional aesthetics rather masterfully and creatively, where she used icons for animals on top to show, which of these have contributed to these strikes, and the splatter of points, as part of the scatter plot provides this visceral reaction to the strikes themselves. The alignment of the charts arguably builds this cohesion by communicating relationships between the various parts, almost like that bento box that you saw on the lunch table. Alignment paradigms might be based around outside borders, titles, and axes, but also the data in itself. And so here I show lines around these key areas of emphasis that highlight how these alignment paradigms at play work in terms of really communicating the data intended effectively. So I provided a bunch of exemplars until now that show how perception, semantics, and intent need to work together as a whole to create meaningful ways for people to see, explore, and interact with their data. So the question you might ask is, so what's next? And I think as we've seen, large language models more lately have gotten, larger. They've had more, new capabilities. More recently, GPT-4o, the new Omni model of GPT-4 from OpenAI can read images and video in addition to, files, and they have advanced analytics capabilities. So, this has really been, I would say, a disruptor in terms of how we think about creating intelligent tools for data. And one thing, to reconcile is, at one hand, we have seen success stories, right, where AI has found to identify a new antibiotic for a certain strain of drug-resistant bacteria. But on the other hand, there's all this, concern around AI and the risk of extinction for mankind. So particularly here at Tableau and on my team, we're really trying to figure out how we can support a human in their cycle of analysis and augment that responsibly with AI techniques to help with that. So I thought I'd kind of show some recent projects that we've been working on that really get into the way of providing that, augmentation to a human in the cycle of analysis. So the first project that I talk about here is called Olio, which really explores what a unified hybrid search experience should look like. And what do I mean by that? So the main idea actually stems from a lot of new ways in which search engines like Google think about unifying the search experience. So again, back in the COVID times, it was pretty common for us to search for new COVID cases in our area, and Google would return dynamic content from a certified data source like Johns Hopkins data, as seen here, to dynamically render a chart or a visualization, but also supplement that with pre-existing content that is relevant to my search query. And so it's essentially creating this hybrid experience around data. And when we think about visual analysis and searching for data and asking questions, we found that a lot of customers have questions about their data that they want to ask, like how has the trend of movie budgets changed over time for different genres? But there's also a great deal of analytical artifacts like Tableau workbooks and data sources that are produced within the organization that they want to search for before they duplicate efforts. So having a way for unifying that search expertise where it can support a question and answering paradigm as seen here, but also return pre-existing content is something that we're working on. And we use GPT to dynamically generate summaries, as you see here, in order to provide additional information and context about the dynamically generated chart. So here is just, a prompt that we supplied to GPT. At this point, it was 3.5, GPT 3.5, to generate this summary. And let me just play a video to kind of walk through what Olio does. So I can type in a question, what are average budgets by genre? And Olio will take that question, try to figure out which certified data source it best matches to. And in this case, movies. It generates a bar chart in descending order, as well as a summary that comes from generative AI, along with a set of relevant workbooks. And here I can ask, show sales across the US. Here, Olio matches to 2 data sets, good old Superstore from Tableau, but I can go in and select an alternative option if that's available, and the system updates accordingly. So this is just an example of creating that unified experience. And another example in this space is really further supporting in the development of natural language interfaces for visual analysis. And there is a continued problem that users face, because even given a data set, they don't know exactly what to explore. And even if they do know the attributes of what to explore, how do they actually phrase those questions in a way that is meaningful to generate any sensible visualization responses? So here's a prototype, Snowy, which actually inspired a new feature that's going GA later this year called Tableau Copilot, that uses generative AI to provide a guided analysis to a user. So here I'm looking at the movies data set, and there's a bunch of attributes on the left side. And if you notice on the right side, there are a bunch of new questions that the system recommends to a user. And these questions are based on certain statistical properties that we derive from the attributes around data interestingness. And so I don't have any follow-up recommendations because my canvas is empty right now, but I can go ahead and click on what is the trend of worldwide growth over the years. And the system generates a line chart. And notice that there are follow-up questions based on what is in my canvas, and the new questions also update. So this guided analysis kind of nudges a user if they want to go deeper into a particular topic or thread, but also if they want to spread themselves more broadly and explore other facets of the data. So in this case, I select this follow-up recommendation, compare across content ratings, and the system generates this multivariate line chart. And then the last project in the space of LLMs and visual analytics is called Data Tales. For those who used to watch DuckTales, apologize if there's an earworm of the DuckTales song going on in your head, but essentially it was inspired by that name. So Data Tales basically addresses this motivation where data stories come in many shapes, but fundamentally they're basically a bunch of visualizations connected by an underlying narrative. And this is something that we've seen a lot of our customers do a lot, where, in some shape and form, when they're sharing content about their data with stakeholders, they have to spend a lot of time creating these data-driven presentations and articles for their intended audience. And so while these data stories are a great way to communicate analysis insights, they are kind of a pain to create. They can be pretty time-consuming in order to create that perfect story. So here we're really exploring how we could use generative AI to provide some initial starting points or multiple versions or varied perspectives based on the audience. But there are challenges, how do you come up with the appropriate prompt? How do you actually use the data and the context to come up with the narrative intent? And, with a lot of these large language models, there's also the danger of errors and hallucinations. And this is something that we really have to pay attention to because, for a lot of these people who are trying to use these GPT-enabled features, there's no room for inaccuracy because a lot of their decisions in their business are based on their analysis and what they glean from a tool. So I'm going to quickly play how Data Tales works. It's a very quick video, but hopefully it'll give you a sense of it. So I start off with a chart. I might select a few marks and I hit generate. That information is passed into a prompt generator, as you see here, and then into GPT to generate this story. And just kind of pausing on the interface in itself, the way we actually get around errors and hallucinations is we have an intermediate layer that takes the GPT output and validates it with the data, the underlying data, as well as the chart to provide some context. And as an author, I can go into my data story, as you see here, select a sentence, and that highlights the appropriate components of the chart for which it is relevant for, and I can also edit the story. So this is mostly providing those scaffolds for managing these story versions, and we're really looking at ways in which we can further provide varied perspectives, also being able to adjust verbosity if someone wants to share this on Slack or Microsoft Teams versus an email or PowerPoint presentation, for example. And so to kind of summarize on where we are with respect to large language models and visual analysis, and particularly working in an enterprise industry like Tableau and Salesforce, trust is a big component of it. You know, LLMs are black boxes, they're not interfaces, so we really don't understand what is happening under the hood. So it's really important when we're designing tools that consume these models to add sufficient guardrails to check for the validity of the output from these models. And we need to provide adequate explanations. Just providing expositions of what is happening is not sufficient because they tend to be very surface level. So providing additional explanations and rationale for why these LLMs come up with specific takeaways is rather important. And we're also working ways to kind of bridge the gap between Tableau's rather complex analytical capabilities, such as LOD calcs and, you know, customized fields, and have a way to use GPT to connect with those analytical capabilities and surface that to a user. And we really need to figure out how we can make the behavior more deterministic, especially when we're dealing with high stakes, you know, decision making that relies on this data alone. So, you know, people ask me, okay, where are we going in terms of data visualization as a community and as research? And I will say, you know, as you've seen in my talk, there's a lot of references to the pandemic, but I think in particular, data visualization contributed to the most iconic visuals at the peak of the COVID-19 pandemic, with a graph showcasing, you know, ability to flatten the curve with specific social interventions and vaccinations, and flatten the curve became an abstraction. And it really was a way to message the importance of active agency and social responsibility for, you know, society to work together to really combat the pandemic. And since the pandemic, we have also seen new domains in which visual analysis and analytics play a role. And, you know, particularly we saw this in the restaurant industry, where the intelligent restaurant movement began to embrace technology to kind of account for, you know, orders and smoothen kitchen management. So we have had the opportunity to work with a lot of local restaurants in the area to show how, you know, they can take real-time information from their sensors and their equipment to explore ways in which they can dynamically reduce friction and backlog through their drive-through experience or food delivery, you know, pipeline, etc. We've also seen a greater degree of data ubiquity with opportunities to explore how visualization experiences can be brought to where people are in their environment, with a lot of smart appliances, as well as equipment on the factory floor. People really want insights to their data where they are without having to walk over to an office and view their dashboard on a desktop. So this is just a kind of a shameless plug to my book, but a lot of the stuff that I spoke today is covered kind of in that book, where we really look at ways in which we think about presenting data to people so that they can understand it. Visualization is no longer a simple graph of data, but it contains a message. It tries to communicate information to us. So how can we use it as a form of rhetoric to spur people to action? And so I do have Bridget and I, my co-author, we came up with this, you know, checklist on various aspects of perception, semantics, and intent that, you know, provide some guidelines as you think about creating visualizations, interactive dashboards, and visualization tools, and what they mean for your target audience to make them useful and meaningful. And with that, that basically wraps up my talk. Here is a link to our external Tableau Research website if you're interested at looking at some of our recent papers, and you can also reach me anytime if you have further questions or comments about the stuff I showed you. But thank you.